Hi to everyone in Yansky online. I am glad to talk to here. This is not my observations made by Radio Whiskey 3 Bravo Papa, Sergey Zhutyaev. But I am happy to present these observations here. They were made by small single dish in very high frequency in millimeter waves, 77 gigahertz. This is Jupiter observations. This is not the dish I am talking about. This is small only on picture. This is actually a huge single dish. But what's next? Jupiter observations in millimeter waves. Why 77 gigahertz? Sergey Zhutyaev, 77 gigahertz. This is frequency of his mining goal for EME, Earth Moon Earth communications, mount balancing. These observations were made as a test for his antenna, but I can told, but they have been made successfully, and I can talk about today. Jupiter radiations is purely thermal in this frequencies in millimeter waves. Brightness, reference brightness temperature is about 170 kelvins. Reference frequency 19 gigahertz. Temperatures is a bit higher than expected from solar heat balance. Jupiter receive a bit less energy from sun than it's supposed that this is thermal flow from planetary depths. Angular size is not too big in the Earth, up to 50 arc seconds and 44 arc seconds in the time of measurements. You can see these pictures. This picture is aurora at the polar point, the polar area of Jupiter, but strong magnetic fields of Jupiter do not affect the surface radiations, and 77 thermal radiation. This is also what can be related to radio Jove, and I decide to talk about this today. Instrumentation used dish 2.4 meter in diameter, mounted on the roof of apartment building in Moscow. You can see place of observations. You can see here, this is a map of Moscow. This is some aside from downtown of Moscow, but but place somewhat sensitive to radio frequency interferences. Okay, dish is mounted dish is rather good, but some surface irregularities are present, and millimeter waves is sensitive to surface irregularities of these observations were made more than 10 years ago. The correcting lens was used 10 years ago, but now Sergey used this dish with Gregory subreflectors. But in 77 gigahertz, this dish works well, even without corrections. You can see the dish with 77 gigahertz receiver in its focal points. How that looks. Aluminum material, dish from aluminum is not too heavy, and well, can be very narrow beam, 0.1 about 0.1 degrees, and at 77 gigahertz. Receiver less than 4 decibels of the figure. Overall system temperature about 500 kelvins, including atmospheric noise. At 77 gigahertz, atmospheric noise contributes to system temperature. Radiometer from Portugal, Luis Cupido designed CT1 DMK designed especially for radio astronomy, bandwidth about 40 megahertz, intermediate frequency 570 megahertz. Okay. You can see about accuracy of surface. You can see map of irregularities of this dish obtained by laser scanning of surface. About 1.3 millimeters of deviations, mean deviations, max deviations about 1 millimeter, and lambda wavelengths of observations 4 millimeter. With these deviations, dish can work at 77 gigahertz. As you can see, a large photo of receiver, very small feet, Skobelev dual mode feet for this receiver, and you can see lens used to correct irregularities of this dish. The lens from special dielectric with low losses in a measured far field diagram of this dish. Very narrow main beam in azimuth slice and elevation slice. Pattern was obtained in 3D, so Surgey can calculate characteristic of this dish. Main beam efficiency about 0.66, and aperture efficiency about 0.53 at 77 megahertz. I think it's very good efficiencies of this dish he obtained with lens. This is more than 10 years ago. Okay, about observations. Observations were made in winter 2014, minus 14 degrees Celsius outside. Very frosty weather. Elevations, antenna elevations more than 40 degrees. Expected levels of Jupiter. Expected levels of Jupiter have been calculated, and calibrations have been made using the moon radiation. Calibrations by the moon radiations. We have temperature data for 90 gigahertz of the moon, about 119 kelvins. This data from these pictures, from this picture 119 kelvins at the center of the disk of the moon, and data was taken from this work. Brightness temperature of Jupiter is known, about 170 kelvins and 90 gigahertz, and data from well user manual 4mm wave telescope in Arizona measured Y factor of the moon is 0.33 dB in the beam. This is a ratio of when a beam looks in the center of the moon, and 1-2 degrees outside, and then we can predict Jupiter expected Jupiter levels from this antenna. More than 100 by this formula. When you know Jupiter angular size and half power of antenna beam, you can estimate expected Jupiter levels, and about results. Results obtained using brief scan of the Jupiter in antenna beam. presented results is after 10 averages of 10 levels of obtained results is about expected. It's well expected. This is certainly a Jupiter. Average, but as Sergey told, averages very helpful because of some flickering of levels observed in frosty air in Moscow, and when hot flow up of hot air from building in Moscow, so some refractions of, in air can impact on the observations. So levels in the well expected by smoothing levels, expected levels and observed levels will coincide. This is good observations made. Something in conclusion, Jupiter can seen at millimeters. Is seen at millimeters by solar radiations and auroras and phenomena in Jupiter atmosphere is not impact on millimeter wave radiations. It can be observable at 77 gigahertz by a small signal dish, as you can see. Results averages is very desirable. It's needed, and atmospheric refractions can affect millimeter wave observations. Results of 10 brief scan averages were presented, and observed levels is well coincide with our expectations and estimations of expected results. This is all I want to talk today. Some questions I will glad to answer.
Do you know what the material was that the correcting lens was made out of?
PTFE materials, but Sergey complained that even this is good materials, but some losses in gain of antenna is noticeable, and why this is why he designed a special Gregory subreflectors for this dish.
Any questions in the room?
Yes, I kind of wonder about how did you manage against water vapor? Because water vapor causes a lot of problems in the atmosphere at that frequency. So how do you manage water vapor?
Please again. You're closer to microphone, please.
The question, Dmitri, was how do you manage water vapor? Because at that frequency, water vapor can give you problems in the atmosphere at that frequency.
Water vapor. Ah,
Water in the atmosphere.
water in the atmosphere. Okay, okay. Losses in atmosphere and this is winter weather. This was winter weather. The water in atmosphere and the losses in atmosphere due to honeyed air and water in the air is very is lower than usually. Is rather low, and more losses in atmosphere is expected from oxygen content of the atmosphere. Oxygen line is 30 in 60 megahertz and 122 megahertz. But oxygen losses is rather high, and water losses is not too high due to frozen air.
Thank you, Dmitri. Any other questions? Any other questions online? Of course, we do have one online. You can always chat through in the chat message as well. Hey, thank you, Dmitri.
Oh, okay, thank you very much.